All right, get ready to dive deep today. We're looking at some pretty cool research on AI video generation. Specifically, how to make it faster. You sent over this paper, FasterCache, training-free video diffusion model acceleration with high quality. And I was like, we have to talk about this.
Oh, absolutely. It's a big deal, a real roadblock in AIGC right now.
For sure. This is work from researchers at the University of Hong Kong, Nanyang Technological University,
Right.
and the Shanghai Artificial Intelligence Laboratory.
Yeah.
And basically, we've got these video diffusion models, right? They can make some really incredible stuff, but man, they're slow.
Yeah.
Like, we're talking minutes to get just a few seconds of video.
It's just not practical.
Not at all. Too many applications need things to be way faster. So the big question here is, can we speed them up but keep that amazing quality? That's what this paper is all about.
It really digs into that, yeah. And tackles some of the problems with the usual tricks, like reusing stuff, caching features from earlier parts of the video creation process.
Right.
Saves time, sure, but you can lose detail.
Yeah, it makes sense. It's kind of like if you were building, I don't know, with Legos or something, and you just use the same block over and over. You might make something, but it's not going to be that interesting to look at.
Exactly, and that's one of the things these authors point out. They're like, hold on. Directly reusing those features, it might not work with how video diffusion models actually do their thing. They rely on making all these little changes over time to get that high quality right.
So you can't just slap on the same Lego and call it a day.
Not quite. And they also say, everyone's been focused on reusing these attention features, but maybe there are better ways to speed things up.
Okay, so what's their solution? What's the secret sauce?
They've got this method called FasterCache. 2 parts to it, really. First, dynamic feature reuse. Think of it like a really smart recycling system.
Okay.
It picks and chooses what to reuse, tweaks things a bit so you keep the details, and everything looks consistent between the video frames.
So not just mindlessly grabbing that same Lego. More like, okay, we could use this here, but let's change it up a bit to fit better.
Perfect analogy. They even give this example of generating a starry sky. With this dynamic approach, those stars stay nice and sharp, but if you just do regular caching, they get all blurry.
Wow, that's neat. So it's tackling speed and quality at the same time. What about the second part?
That's called CFG-Cache. CFG stands for classifier-free guidance. It's this technique that helps boost the quality of the videos these models make, but it uses a lot of computing power.
Classic trade-off, right?
It always seems to be. But here's the thing. They've realized that the stuff CFG makes, within each time step, it's actually super similar. So instead of storing the whole thing, they're like, let's just store the differences. It's kind of like compressed files, but for video generation.
So they're not rebuilding from scratch every time, just storing the little tweaks and adjustments.
Smart. Right. And then they go even further. They dynamically boost certain parts of the video, the high and low frequency components, and that helps improve things visually while saving on computation.
Hold on, now I'm a little lost.
Yeah.
What are those components in this context? Like, are we talking about audio frequencies but for video or something?
Yeah, that's a good way to think about it. Basically, the high frequency stuff is all the fine details, sharp edges, all that. Low frequency, that's more like the bigger picture, the overall shapes. Think of it this way. High frequencies are like individual leaves on a tree. Low frequency is the whole shape of the tree.
Okay, that makes sense.
Yeah.
So boosting both make sure the video has detail, but is also like structurally sound.
You got it. Pretty slick.
Right. Super clever. But the proof is in the pudding. Did this FasterCache actually deliver?
They put it through its paces, that's for sure. Tested it on a bunch of popular video diffusion models like OpenSora, Latte, CogVideoX, all those. And different sampling schedules, resolutions, video lengths, the whole works.
That's a pretty thorough test drive. What were the results? Did it work?
The results are pretty impressive. They saw speed improvements up to 1.67x compared to the regular models.
Whoa. That's a huge jump. But did they have to, compromise on quality to get that speed?
Nope, that's the best part. The visuals stayed just as good as the baseline, so big speed gains without losing fidelity.
Okay, now this is getting really interesting. Sounds like they might have actually cracked this whole speed problem with AI video generation. But I'm sure they didn't stop there, right? Did they try to figure out why FasterCache works so well?
Oh, they did. They did this thing called an ablation study. Basically, they took FasterCache apart, piece by piece,
Like taking apart our Lego creation to see which blocks are really important.
Exactly. And they found that both parts, the dynamic feature reuse and the CFG-Cache, they both played a big role in making things faster and more efficient.
A true dynamic duo. I want to hear more about what they discovered about each part, but I think that's a good spot to pause for now. We'll dig into those findings when we come back.
All right, welcome back. So before the break, we were really getting into the nuts and bolts of this FasterCache, how it speeds up AI video generation. And now it's time to dive into what they learned from that ablation study.
Yeah, let's hear it. Because it's one thing to know something works, but it's way cooler to understand why.
Totally. So they found that this dynamic feature reuse, it wasn't just saving time, it was actually super important for keeping those fine details from getting lost. Remember that example with the starry sky?
Why?
Well, they also tried it with a moon and a snowflake.
Okay, getting a little more complex than Legos now.
Yeah, true, haha. But the idea is similar. With that dynamic feature reuse, all those little details on the moon's surface, the intricate shape of the snowflake, they all stayed sharp. But without it, forget it, just a blurry mess.
So it's like a built-in quality check. Make sure those tiny details don't get sacrificed just to make things faster.
Nice. What about the CFG-Cache? What did they learn about that? Now that's where things got really interesting. Turns out that CFG-Cache, with that fancy way it boosts the high and low frequency parts of the video, well, it wasn't just making things faster, it was actually making them look better in some cases.
Wait, hold up. Better? I thought the whole deal was that you had to trade off quality for speed.
Right, that's what's so cool about this. They give this example of some clouds and lightning in one of their tests. And with the CFG-Cache, those elements were way clearer, more detailed than the original model.
So not only is it making videos faster, but it's like upping the visual game too. That's a pretty big deal for all sorts of AIGC stuff, right?
Huge. This could completely change how we do things in entertainment, advertising, even scientific visualization. Imagine making super high-res video in real time for games, or ads that change based on what the person watching likes.
It's mind-blowing. And it's not just about like making things look flashy. This could change how we learn and share information too. Think about videos for school that are different for each student, or science stuff that lets you see complex data in ways we can't even imagine yet.
Exactly. And this is just the tip of the iceberg. As this tech keeps getting better, who knows what we'll be able to do? The researchers even mentioned this idea of adaptive caching, which could make things even faster, especially for those crazy action-packed scenes.
So they got these great results, but they're already thinking about how to make it even better. That's pretty cool.
No, science, right? Always got to keep pushing forward. This paper, it's opened up this whole new path for speeding up these video diffusion models, and it's going to be wild to see where it goes from here.
I'm with you. This deep dive has been amazing. I feel like I actually understand this FasterCache stuff now and why it's so important for the future of AIGC. But before we wrap up, what was the thing that stood out to you the most about this research? Anything that really clicked?
What impressed me was that they really went for both speed and quality. A lot of people would have just focused on one or the other, but they knew both were important, and the way they solved it, super clever.
It reminds me that the best tech, it's the tech that solves real problems. And in this case, they tackled this major slowdown in AIGC, which could unlock so much creative potential.
Couldn't have said it better myself. This isn't just about making things faster. It's about giving creators new tools, new ways to do amazing things with AI.
This has been awesome. Thanks for walking us through FasterCache. I think our listeners are getting a lot out of this. But before we go, what's something we can leave them to think about? Any parting thoughts or questions to get those creative juices flowing?
Well, we've been talking about all these possibilities. FasterCache opens up, right? So I want to challenge our listener to really think about how this tech could totally reshape the way we make and experience video. In the future, I mean.
Oh, yeah, that's good. Get those creative gears turning. All right, like we talked about the techie stuff, the potential uses, but now I want to hear those wild ideas. What kind of stories could we tell? What totally crazy out there stuff can you imagine doing with this?
It's so easy to go straight to entertainment, right? Imagine movies or video games that are interactive, where the visuals, they just change in real time based on what you do.
It'd be like living inside one of those choose-your-own-adventure books, but as a movie.
Totally. But think bigger, beyond just entertainment. What about learning? Personalized lessons where the video changes based on how each student is doing.
Oh, and what about documentaries? Imagine if they could, stay updated, always have the latest info.
Whoa, a living documentary, constantly evolving, making us question what we think we know. That's powerful.
And this isn't just about the content. It could change how we watch videos, too.
Yeah.
What if we could search for specific moments just by, describing what it looks like? Or have the AI make a summary just for us based on what we're interested in?
We'd have so much control, so much more interaction with the video.
It's exciting,
Right.
right? But also kind of scary, Like, we're on the edge of this huge change in how we make, share, experience video. And who knows what'll happen.
Yeah, feels like a whole new world. But the best part is, this isn't just sci-fi anymore. It's real, it's here, and it's only going to get crazier.
Absolutely. Well, I think that's a great place to wrap up our deep dive today. It's been fantastic exploring FasterCache with you. Hopefully, our listener is walking away understanding just how powerful AI video generation is becoming.
I hope so, yeah. And remember, this is just the start. Everyone listening, stay curious, check out the code they mentioned in the paper, maybe even get involved in this whole field of research.
Who knows, maybe someone listening right now will be the one to come up with the next big breakthrough in AI video. The future is out there for the taking.
That's right. Keep learning, keep pushing the limits, see what you can do with AI.
And that's a wrap for us. Thanks for joining us on this deep dive into FasterCache.